So today we want to start off with temperature conversions using decimals. As I said a minute ago, that the temperature conversion is the same as we saw before. Instead of using 9 over 5, we're going to use 1.8, which is essentially 9 divided by 5. You get a decimal. So the calculation is the same. Formulas look a little different, and I'll put those in the notes. So they look like this here. And for people who don't like fractions, these ones are nicer than fractions because they don't use fractions. They just use 1.8 and 1.8. One time they divide, one time they multiply. So let's have a look at some questions involving those. Shouldn't be too hard because we've already done it. So look at 12 degrees Celsius to Fahrenheit. So we're converting into Fahrenheit. So we're going to use the formula right here. We're going to use this one. Celsius times 1.8 divided by plus 32 is degrees Fahrenheit. So back here, I'm going to write that down. We have Celsius times 1.8 plus 32, and that's equal to our Fahrenheit. So if we have, this is number 1. So we had 12 degrees Celsius. We'll substitute 12 degrees in right here. 12 degrees substituted in, multiplied by 1.8 plus 32. That gives us an answer. So we'll just throw it in our calculator. So it looks like this, 1, 2, multiplied by 1.8, and add 32 plus 32, gives us 53.6, and I'm rounding up to 54. 54 degrees Fahrenheit. I'm going to try number 2. You can look at 42 degrees Celsius. 42 degrees Celsius rings a bell to me. When I smile or laugh, I have a story about it. So we have our formula again, Celsius multiplied by 1.8 plus 32 equals degrees Fahrenheit. And I'm going to put my 42 in for C. 42, oops, 42 multiplied by 1.8 plus 32 equals, and in our calculator we're going to go 42 times 1.8 plus 32, and that equals 107.6, or let's just say 108 degrees Fahrenheit. And let me tell you, that is really hot. It's really hot. In the summer of 2017, so not last summer, the summer before that, myself and a colleague of mine got the opportunity to go to Las Vegas for college to a conference there. And one of the days we were there, the outside temperature was 42 degrees. So it was 108 degrees. It was in the desert pretty much, right? So it was 108 degrees. You go outside, and I mean, you know, you feel the wind. If you use the wind, it's kind of a cool breeze with wind. This wind was a hot breeze. It was just unbearable. It was just crazy. Just you go out there, it's blowing, it's almost burning you. The wind was. So I was like, this is hot. This is really hot. So, in case I'm not complaining about the heat, because we'll have snow soon up here. Let's try some other examples from changing into Celsius. Oops. Let's try these two. So we'll get the formula for Celsius conversion. It's going to be Fahrenheit minus 32 divided by 1.8 gives us our degrees Celsius. I want to point out this time, it's very important that we use the brackets this time. Last time it didn't matter back here in this question. We talked about it before when we did this conversion last time. Here we have, the calculator would automatically do multiplication before addition anyway. So if you forget the brackets or mistakenly leave them out or don't want to use them, it doesn't matter. But in here, either you use the brackets or you total up this piece first, then divide it by that piece. Because the calculator will do dead mass first. So we just put this in a calculator like, I'll just show you. I put it in 101.5 minus 32 divided by 1.8. Let's have a look what happens. And just because it's a calculator doesn't mean it's always right. I mean, it will make calculations, but if we put the numbers in wrong, it's going to calculate them wrong. So if I have 101.5 minus 32 divided by 1.8 equals 83. So how about if I did this brackets 101.5 minus 32 brackets divided by 1.8, you get this number, 38. Which one's right? Going to brackets. Because what happens, if we do this piece right here, we put it in the calculator and don't use brackets, what's going to happen? The calculator is going to use BEDMAS and it's going to do this piece first. Because it's going to apply BEDMAS. The only way we can get around that is by taking this and say, oops, go over there, don't want that. We want to put brackets in here and here. Now we force it to do the subtraction first, then the division after. So, we just did the calculation, so I might as well just put it up there. 38.6. Oops, a pen would be nice. .6 degrees, that's our Celsius temperature. And this is number 4. Number 4 is very colorful. Hope you like colors. So let's try number 5. This one is, hang on, I just noticed something. I think it's a typo actually. Let me think about this for a second. Yeah, typo in the book. Yay! I did it. I overlooked the typo, but in case you didn't catch it, I'll show you where it is. Right here. We're converting 101.5 degrees Celsius into degrees Celsius is going to be 101.5. So I'm pretty sure they meant this, because 101 degrees Celsius is really, really hot. So I'm pretty sure they meant this to be Fahrenheit. That's what we took it as. That's what I used as anyway. So, but yeah. So there you go. So it's Fahrenheit. Well, I can't even imagine 100 degrees Celsius at 46 to 40. I said 42 was unbearable. 101 must be melting things. Okay, so there are a few mistakes in this textbook that I've come across over the last few years. I guess that's a new one for me. I haven't seen that one yet, but I'll point them out as we come along with them. But it's better than the other textbook we used, because the other textbook is full of mistakes. Crazy. So using the formula again, we have for number 5, Fahrenheit minus 32 divided by 1.8 is degrees Celsius. So 46.6 minus 32. Put in our brackets divided by 1.8 Once we have that, we can just go ahead and put it into our calculator. Now we know how to enter it properly. So 46.6 minus 32 divided by 1.8, 7.8. Notice I didn't use brackets in my calculation. But what I did, I totaled it up here first before I divided by 1.8. And that's fine too. Actually, that's wrong. What's wrong with that question there? What's the mistake? Can you see it? The calculator gave me a number. Awesome. Is it the right number? You see the display there, and you see the question I'm working on. See any problem? The 6 didn't go in here. The 0.6 didn't go in for some reason. So let's try that again. 46.6. Okay, let's use brackets this time. 46.6 minus 32. All the brackets divided by 1.8 equals, there we go, 8.1. So it's always never hurts to double check your work. .1 degrees Celsius. Sounds good. Any questions on that kind of stuff? With the 2 converting into Celsius and 2 converting into Fahrenheit? It's basically the same as you already did, just use decimals instead of fractions. Only caution area is the brackets there. Are we all cool with that? Okay, so I guess we'll move along to the last section of this chapter. Solving mixed fraction and decimal problems. Does it get any worse than this? I don't think so. Wrong page. My bad. So I'm going to run through this example, and I want to do it by hand so you see what's going on here. So I'm doing it slowly, and I want to do it 2 ways. So first of all, looking at here, I mean, this gets pretty nasty pretty quick. Looking right here, you see that we have a complex fraction right here, multiplied by a decimal right there. We're like, really, oh my. Well, not so bad. Break it down into pieces that we can deal with, right? So we have 1/2 divided by 1/5, which basically this piece turns into this piece right here. And we know there's no such thing as division of fractions because it's just turn upside down and multiply, which gives us this piece. And 5 times 1 is 5, and 2 times 1 is 2. So the solution to the first part is right here. So we have 5/2 turned into a decimal by going 2 into 5. 2 goes into 5 2 times, which is 4. Subtracting 1. So I have 1 over 2, or 2.5. Once I have that number, then I just multiply them together. Multiply is normal. Okay? So I'm not going to just leave it like that. I'm going to take this and work it out a little more slowly so you see what's happening. Because it looks really confusing from the start. 1/2 divided by 1.1 over 5. So I'm going to have 1 over 2 over 1 over 5 multiplied by 2.2. So I'm going to divide the screen into 2 pieces, like this. 2.2. This I said 2.2 and I said we're on 2.1. Yeah, my bad. Funny how that happens. Brain damage. So I'm going to divide the page in half, like this. I'm going to work it out one way on the left side, another way on the right side. So you see, it's more than one way to do math. First, what I'm going to do is, like you've seen me do many times, cover this piece up. Just work on that piece there first. And that piece is going to look like 1 over 2 divided by 1 over 5. I can sneak this piece down if I want to, so I don't forget it. And this becomes 1 over 2 times 5 over 1 times 2.2. Let me see, it's 5 over 2 times 2.2. Changing this one into a decimal, we know that it's going to be 2.5. And we have 2.5 multiplied by 2.2. 2 5s are 10, 0, and carry 1. 2 2s are 4, 1's 5. And 2 5s are 10. Carry the 1, 2 2s 4, 1's 5. Add them together, we get 5, 5, 0. We have 2 decimal places. So we put a decimal in right here. And we're done. Sounds good. But we could do this. Start off the same way, essentially, where we have 1 over 2 over 1 over 5 times 2.2, which turns out to be 1 over 2 divided by, this is actually 1.5, fix that. 1.5 times, let's take this one here, and remember we did a few minutes ago, or yesterday or last class, we were dividing, or changing decimals into fractions. Let's just take this and change it into a fraction. So we actually have 22 over 10. Remember that? Remember a while ago? Now I take the first one, we have 1 over 2 times 5 over 1 times 22 over 10. Now, you know, I know you don't like fractions, but sometimes fractions can be your friend if you get used to them. This comes down to 1 times 5 is going to be 5 over 2 times 22 over 10. This is a 10. And now it's basically just multiplying fractions. So 5 times 22. 2 5s are 10, 31, 10. Let's see. 110. And the bottom is going to be 20. Right away what I can do, when I have that, I can just go, that 0 is gone, that 0 is gone. I can reduce it to 11 over 2, and that becomes 5.5. So you can do this question by converting it all into decimals and doing it, or by converting decimals into fractions and doing it from there as well. So there is more than one way to do math, which lots of people don't realize. And both of these solutions are equally correct. If you use either one of those in the test, you should be fine. Let's try this one here. So I have 1 over 200 divided by 1 over 100 times 4 over 4.4. So let's just have a look at that for 1 second and break it down. It's going to be 1 over 200 divided by 1 over 100 times 4.4. So this turns into 1 over 200 multiplied by 100 over 1 times 4.4. I brought my pen into the IT department yesterday and they did something with it. I don't know what they did, but it hasn't misfunctioned yet the whole day, so I'm really pleased with the way this is working today. So I have 100 over 200 multiplied by 4.4. Let's do this the easy way, because I've got two zeros top and bottom. Let's reduce it and reduce it. So basically this boils down to 1 over 2 multiplied by 4.4. And because it's 1 over 2, we know that 1 over 2, just by seeing it around enough times, we know that's going to be 0.5 times 4.4. So what we do, we go 4.4 multiplied by 0.5. It looks like this. So I go 5 fours, 0 and carry 2, and 4 5s is 20, so it's 22. You see we have two decimal places, so I took my decimal, which is right here, and I move it right over here, so it's 2.20. Again, if you didn't like that, right here, you could have easily went like this. You could have easily went and gone 1 over 2 multiplied by 44 over 10. And you would end up with 44 over 20. And dividing that would still give you 2.20. So I'm assuming that people don't like this idea as much because I know you don't like your fractions, but sometimes it can make it a bit easier if you just switch it out in fractions. If you don't mind fractions. If you don't like fractions, totally disregard the whole fraction section of this octagon. It's just easy as that, and play with the decimals if you prefer decimals. Okay, and just watching the time, keep an eye on the time, but this one here is a really interesting one. It's really going to pretty much apply everything you learned about so far in one question. Yeah, I know you're gonna love it. Notice this question. We have a mixed number divided by a mixed number multiplied by a decimal. You gotta be kidding me, right? You're killing me here. So before we freak out, let's take the pieces that we know, take 7 and 1/2 and turn it into a improper fraction. So it's gonna look like this. Take the top. So remember we said 2 times 7 plus 1, it's gonna be 14 plus 1, so it's gonna be 15 over 2. And the bottom is gonna be 1 times 2, which is 2 plus 1, so it's gonna be 3 over 2 multiplied by 5.4. Now it's back to what we had already, just improper fractions, but it's going to behave exactly the same way. I'm going to have 15 over 2 divided by 3 over 2 times 5.4. Taking 3 over 2 and turning it upside down, or in other words in math world it's called reciprocal. Remember that word? I hate that word. So long, I hate writing it out. I think last time I had a car in the garage, my reciprocal was broke and they fixed it for me, so I didn't talk about it anymore after that. It was expensive too. Whenever you get your reciprocal replaced, not good. So you can use big words like that just to be impressive. That's what I use them for. Times 5.4. This works out really nicely because before we do any multiplying, you can see that using a shortcut from earlier in the chapter, we can cancel out these 2's right away. And now it turns into something like this, which becomes 15 over 3 times 5.4. And once again, it becomes really nice because 15 over 3 is just 5 times 5.4. And if I were to put those like this vertically, 4 5s are 20, 0, and carry 2. And 5 5s is 25, and 2 is 27. 27. I have one decimal place. One decimal's going to go right here. And the final answer is 27. That's probably what the worst you're going to see, because it started out with a mixed number divided by a mixed number multiplied by a decimal. It's like, does it get any worse? But actually, when you see it, as you get through, it works down to a nice number of 27. Not too bad.